here's what we got. We're gonna start off with this problem right here. And actually gonna change up the problem. So we got ourselves. You ever rock climb, Isaac? I love rock climbing. It's like one of my favorite things. This was, of course, when this was like 40 pounds ago. Um, be careful when you get married, Isaac, because you gain a lot of weight when you gain a lot of weight when you're eating home cooked meals from your wife. Anyway, I used to do a lot of rock climbing, and let's say that we find ourselves in a situation, and this isn't a true story, I've never actually found myself in this situation, but let's say that I fell off the edge of a cliff. There's me. Cool. But I had a rope attached to me. And what you did is Hollywood style. Isaac, you jumped and dove and you caught the rope. And you're holding onto that rope. Because you don't want your teacher to die because he's a really nice guy. So you're holding onto that rope, and so here's my question: is how is this thing going to accelerate? What is acceleration? Um, why don't we assume that I'm fatter than you are, or I'm heavier than you are, which is not that far-fetched of an assumption. So we have M1 and M2, and in this case, M1 is smaller than M2. We know that. So let's start off with what are the forces that you see? Yeah, let's start off with M1. So, all right, so you got the weight of you, which goes straight down. I'm going to call this weight 1. Here we go. The normal force. I'm going to call that N1. And friction. Friction is going backwards like this. Oh, we need to assume. I forgot to ask you. How are things going to move? Well, if I'm heavier than you, I know that I'm sure you will save my life. But if I'm heavier than you, and when we get to this topic called torque, I'll show you how you did actually save my life. But um, when um, for now, we're going to assume that things kind of go in a clockwise direction. I actually start going down, and you start going sliding up. Because remember, I'm heavier than you are. Cool. Alright, so you got your weight going down, you got the normal force, your thing is at an angle theta. There's one more force on you that you didn't. Alright. So that's all the forces to me. Well, you see, alright, so now let's move on to the next person. There's the weight. Yes, that's true. This is the weight too. And then what else? And we also have tension. Yeah, that is it. Okay, cool. Now we're going to do something funky with the coordinate system here. For the coordinate system of 2, why don't we start off with that guy? That guy's the easiest kind of coordinate system to deal with. What does the coordinate system look like? Yeah, there we go. Positive y direction going that way. Okay. Now, for the coordinate system of u, how do you want to call that one? I know that it's a little funky, but I'm going to call it this way. You know, that usually looks like X. Why do I do that? Because if this guy's going in the positive y direction, that actually means that this guy's going in this positive direction, positive slanted and up to the right direction. So I don't want to confuse, I don't want this to be like, this guy's moving in the X direction while this guy's moving in the Y direction, and those two directions are connected to each other. Does that kind of make sense? Alright, cool. So you need to test with that one. Alright, so let's do this problem. Why don't we add up all of the forces in the Y direction? Cool. And you know what? You know what we can do is technically, instead of breaking, for the other problem, the Atwood machine, that's what this thing is called, you can actually do the sum of the forces on the entire system at one time. So what I'm going to do is, alright, first we need to ask ourselves, is the acceleration 0? Negative cap. So we're just going to leave it. And instead of mass, I'm actually going to have, okay, well that's mass 1 plus mass 2 times acceleration in the Y direction. Sound good? Because that's the mass that we're talking about, both of our masses. Alright, and so that's equal to, add up all the forces. So what forces do you see in the Y directions? There's tension. Now, this is a little bit confusing because there's two tensions I see, you know what I mean? Well, see, that's the thing. Okay, go ahead. Wouldn't they cancel each other out? Yes, absolutely they would cancel each other out. Tension is kind of an internal force that's kind of acting between these two systems. So technically you don't even need to include it, because this tension pulling this way will be the same as that tension pulling that way. You see what I mean? Yes or no? Let's focus on the tensions. If we have this guy as tension 1, right? And he's going in the positive Y direction. Tension 2 is going in the negative direction. But T1 is equal to T2, so that's 0. So essentially you only need to include tension in that if you're talking about the whole system. Alright, so no, don't put tension. And dash it all, before we get started, I forgot to do something because it's very important. I see a vector that is going off at an angle. Which vector is that? There's only one, really. Do you see it? There's a vector that's going off at an angle that I need to break into its components. There's only one of them. Which one is it? Ah, very good. Because we call this the positive Y direction. This guy needs to be broken up into its components. Does that make sense? And this angle right here is theta. Did you prove that to yourself? That that's theta? Okay, cool. Alright, so this would be weight cosine or sine? There we go. And this is weight sine theta, as obviously. Okay. Alright, now let's add up all the weights in the Y direction. What forces do you see in the Y direction? Alright, so it's negative friction. Minus W1 sine theta. What else is here? Plus W2. That's it. Sound good? Okay, cool. Alright. Friction is mu times m. So that's mu times the normal force minus m1g sine theta plus m2g equals m1 plus m2 times the acceleration in the Y. I'm not going to put acceleration in the Y direction because when we look in the X direction, it's not going to have any acceleration whatsoever. Cool? Alright, so now I'm kind of stuck because I know everything except what the normal normal forces. So we should go sum of the forces in the x direction is equal to mass times acceleration in the x direction. Cool? What, my friend, is the acceleration in the x direction? 0, because the acceleration in the x direction is actually technically going this way. It's kind of funky like that. It's so funky that I actually wrote y instead of an x. There we go, it's 0. See, this guy's not going right or left, and this guy's not going up or down. So it's 0. Well, I'm cool with that. Alright, let's add up all the forces you see in the x direction. What do we got?
Isaac, which force do you see in the x direction?
Alright, so we've got the normal minus w cosine theta is equal to 0. So that's telling me the normal is really equal to w cosine theta. We go with that? Alright, so then you take this n, you plug it into here. That's it. That's it. We pretty much finished the problem. Do you mind if I'm going to rewrite this guy right here, but instead I'm going to switch him around, and I'm also going to replace n. Tell me if I mess up in all of the many things I'm going to do in my head at the same time. Theta minus mu times the m. Oh, by the way, this is way 2. m2g cosine theta equals
m1 plus m2 all multiplied by a. Did you get what I did?
Yes. What did I do?
Yeah.
I rearranged terms, replaced n, and I even replaced the w2 with an m2g. Alright, now what you can do is you just take everything that's not an a, which is all of this guy right here, and drop him down slopes. All divided by m1 plus m2 equals a. Okay? And this, my friend, is the answer.
Now, what is the physics telling us? Well, here's what the physics is telling us. What if theta were 90? What if theta is
90 degrees?
If theta equals 90 degrees,
I'll tell you what, the sine of 90
is equal to 1. And the cosine of 90
is equal to 0. So if you plug in 90 degrees into here, what's going to happen is your equation is going to be, this is going to be 1 and this is going to be 0. So essentially you're just going to have
m2g minus m1g all divided by m1 plus
m2 equals a.
Do you agree? Alright, check this out. Why is it different? Well, because
in this scenario, the m1 was heavier than m. Yeah, in this scenario, m2 is heavier. And, yes, of course, that makes sense, because if you made this thing 90, if you made that angle 90, wouldn't it be exactly that same exact situation? Haha, isn't that cool?
Alright, then what you do is you do this.
Check this out. You solve this problem right here, and you'll get, I'll tell you what, I'm not going to solve this problem. I'm going to leave that one up to you. You can solve that on your own. I think I even solved that for you at one point in time, but I'll tell you what the answer will be. The answer will be this. If theta was 0, it would be that. So your answer would be m2g minus mu times m2g divided by m1 plus m2 all times a equals a. How do I know that? Because the math, I trust the math. It's going to work out. Alright, we cool? That's it.